Hello sir, we are group 8 and we are here to present our smart system for microcontroller and embedded software assignment. So the smart system that we decided to go with was a smart hospital system. The reason why we chose to do this system is because we believe that in this day and age, technology is paramount in most of our daily applications. As such, we decided to implement a smart hospital system so that we can simplify the work of medical professionals. Our smart system is divided into 4 subsystems. It includes the patient vital monitoring, the bed monitoring, the inventory monitoring, as well as the room environment monitoring system. Now I will go into details of my part, which was the patient vital monitoring system. So my system makes use of an ESP8232 sensor, an OLED, an RGB LED, as well as a MAX 3100 pulse oximeter. The purpose of the AD8232 is to measure the patient's pulse readings through the electrodes. So by implementing these, we're able to simulate the waveforms that appear on an ECG monitor. Then the purpose for the MAX 30100 is to read the SpO2 of the patient as well as the patient's heart rate. So putting all these systems together, I displayed the results on the OLED as well as a Python application. So here, the waveform of the patient's heart rate is displayed in the form of similar to how an ECG monitor works. So when the patient places the finger on the pulse oximeter, it measures the heart rate as well as the SpO2 readings. Then, using this temperature sensor, the patient's temperature is also measured. So as you can see here on the OLED, the readings are displayed. And in our Python GUI, these readings are reflected on it as well. Here we have the waveform display, and here we have the patient's heart rate, SpO2 readings, as well as the temperature. That was the patient vitals monitoring subsystem. Now I'll pass it on to my group member to go over the bed monitoring system.
Hello sir, my name is Farhan. So I will be explaining my part about the smart bed system in the clinic hospitals. So this is my system. We got a bed, water sensor, and a nurse calling button, and some PIR sensor which will detect the movement, any motion in the room. And on the screen it will show the data, whatever it is being there, but there's a delay of 5 seconds. After 5 seconds it will show like whatever is going on. So we'll start from bed system. So we are using the LDR sensor, which will show if the patient is sleeping on the bed or no, or if the bed is occupied. So here we are. So as you can see, the bed is occupied, resting. We will show on the screen as well. It is a delay of 5 seconds. Now it's showing that yes, the bed is occupied. Now we will move our finger. No, before we move, we have to show that there's a movement, or if the patient is moving on the bed. The LDR sensor, the PIR sensor will detect if there's a movement. We also will show on the screen if there's a movement or no. There's a delay of 5 seconds. Yes, there's a movement. Now we will remove our fingers. Consider as the patient is moving or getting up from the bed. So soon we remove our finger. There's a red light beep. It will alert the nurse that the patient is not on the bed anymore. So we introduce a button which will close the beeping sound, and now it's been shown that bed is empty and there's a movement in the room because LDR is active. We will show it on the screen as well. Bed is empty, movement in the room, and Right now the nurse calling button is off and the water sensor is also no, right there's no water detection. Now we will try to do one thing. We will try to click the nurse button. It will show. Just a minute. Okay, we click this button to call the nurse if the patient want to call a nurse. Okay, we will say that it's active. The nurse calling button is active. We will close it back. It's back to normal. We will show here as well. After delay of 5 seconds, after 5 seconds it will show that the button is off. That was the one part. Now we will try to check the water sensor if there's any leakage or maybe water has fallen on the bed or any kind of like patient has there's something on the bed, something like that. So we will detect it by applying some wet tissue and it will show on the screen, and automatically it will alert there's a water detection. It will show for 3 seconds and then there's a red light for the water detection, and automatically a nurse calling button is activated. So to turn it off, we click it back. All right, it's back to normal. It's back to normal. We also show here the water leakage. Now since 5 seconds we already removed that, it is back to normal. That was one part. Now the second part is the LDR. Right now there's a movement in the room. What if there's no movement in the room? We will move back. Can you zoom in? So within 10 seconds, if there's no movement in the room is considered as empty. As you can see, there's no movement. Alright. So there's a timer within 10 seconds. Within 10 seconds, if there's no movement in the room, that means there is nobody in the room. The patient has moved away or anyone in the room has exit the room. So that was for the part to be if either the room is occupied or no. One more thing is that my things are getting displayed over here through the Wi-Fi, but my Arduino Mega doesn't have the Wi-Fi. So I'm putting my data to the Arduino SP32. From through here, it is going. The data has been transmitted to the Wi-Fi GUI over here. So that was my part, and that was my part for the smart bed system. That's enough. Thank you. So this was my part. So this was my part about the smart monitoring system of the bed, and thank you for your time. And now I will bring another friend of mine to explain his part.
Hello sir, my name is Obura Ianomonda. Now I'll show my subsystem. For my subsystem, I was doing the room environment monitoring system. For this, I took into account measuring the weather conditions such as the temperature, the humidity, and the air quality, plus the light. So for my microprocessor, I used the ESP32. I used the MQ135 for measuring the air quality, an LDR sensor to measure the light in the room, the DHT22 to measure both the temperature and the humidity. So when I reset my process, so when you come to the screen, you'll see that the temperature shows 28 degrees, the humidity is 83 degrees, the light is 3%. It shows the air quality also as well, which is 266 ticks. Now when it comes to showing the conditions, right now it shows that the temperature is hot, the air quality is good, but it's nighttime, and as you can see, by the time we're recording this video, it's actually nighttime, so which shows that the LDR is working perfectly. Now when it comes to the setup, this my LED flashes red for in case any one of the conditions isn't met right. So as you saw on my screen, the temperature is showing hot, which is not a conducive environment. The temperature for my hospital, the room, should be 26 or below. Right now that it's recording 28.9 degrees Celsius, it's considered hot, although the air quality is fine. The time of the day doesn't dictate the color red of the LED. So it's only the temperature and the humidity. So since it's hot but with good air, the nurse is informed and they come and check check on the temperature to make it more conducive for the patients. With my project, I also was able to use Blink to monitor the different temperature conditions. So this is the gauge for the temperature, the humidity, the air quality, and the light level. And here it shows the overall status. So it shows hot, good, and nighttime, the air quality. So on the group part, we designed a Python GUI that monitors the temperature also as well, the humidity and air quality, plus the light level. So as you can see, the values keep on changing. So now I'll demonstrate the working of my DHT by blowing warm air on it. So now you can see that the humidity and the temperature have changed. 30 and 100, initially they were 88 and 27. So now I will blow this. Everywhere. So as you can see, as we blow clean air onto the DHT, the value of the temperature and the humidity changes. With that concludes my room air quality measuring system, which demonstrates a live capture of all the different weather condition parameters, and that's the end of my subsystem.
So my part will be the smart inventory system for the smart hospital. So I'm using ESP32 microcontroller, and then I have a buzzer to notify when the stock gets lesser. I have a LED bulb to notify when the stock gets lesser. I'm also using an OLED, and then the button here is to save the weight of the empty box. So to check the weight of the inventory, I'm using HX711 and a load cell. So first, I weigh the weight of the empty box and press the button, so it saves the weight of the empty box. And then I put the medicine stripes inside. The medicine stripe inside here, the box, and then weigh it again. It shows the total weight, and each stripe has its own set weight. So the system takes the total weight and minus the empty box and divides it by the stripe that is there to give the total number of medicines that stocks available. So as the stock gets lesser, it reduces. And here in the GUI, you can also update, as in for restocking or checking. If you put the name of the medicine and then the new stock list, and you key in the expiry date, it will be saved here, so it shows the total number of inventory in the system. Okay, so now I'm going to show you the demonstration. At the GUI here, the medicine shows 4, the stock is 4. It means it has 4 stripes inside. So now, as I remove this, it's already showing low stock, so the buzzer is working, and the LED is showing that it's, because everything is taken, so it's like low stock. as I place it back again, the GUI shows 3, means the reduction that I have removed the stripe from inside, and it shows that the stock is reducing. So it successfully shows, and it shows 3. So whenever it goes below 4, it is meaning that the stock is low, and the LED and the buzzer also works, means that the inventory is below 4, and then it should be restocked. Thank you. Thank you, sir.
So sir, that has been our presentation of our smart hospital system. Though this assignment proved a bit challenging for us and we experienced a lot of technical difficulties, we still managed to produce our smart hospital system. Thank you, sir.